Hi, everyone. Thank you very much for inviting me. And I'm very happy to speak about Finite's state machine on the front-end topic. So my name is Eugenia, and I currently live in Berlin. I work as software engineer at Raisin. Raisin is a fintech startup which is a platform for savings and investments, and Raisin is also in the UK. I'm a former Google Developer Group organizer and Women Tech Makers lead, but it was a few years ago when I was living in Latvia. So I was also organizing some meetups and conferences as well. It's a super nice thing. Thanks for doing it. You can find me on Twitter. And I also sometimes post some articles about topics like web performance or state management in the front-end application. So finite state machine, a little bit of theory, because I assume that not everyone faced this concept before. You could meet it in the university on the Automata Theory lessons. How is it called? Yeah, I think it's Automata Theory lessons. But that's why I still think that some people, it's totally okay if you don't know it. And here is a short theory. This is actually quite old mathematical concept, which is around 60 years old. And here you see the visualization of an abstract state machine. And the main idea here is that a state machine can be only in one state at a time. And here the circles represent the states and the arrows represent transitions between state. And a transition can happen only in response to external inputs like input A. For example, if a machine is in state S1, it can transition to the state S2 if it received input A. This machine has initial state and also a final state. One of the simplest examples from the real world is a traffic light. There are 3 states in total, green, yellow, red, and the transition between them is happening in response to timer events. And it would be a pretty bad situation if this state machine could have 2 states at a time, like red and green simultaneously. I have prepared a small application which is doing just file upload. And I will refer to this flow further in my slides. But let's take a look what it is doing. So there is an add attachment button, and user needs to select a file. And when it's done, we show loading indicator. And then when file is successfully uploaded, the request is successfully made, then we show success. However, if something is wrong with a file, request failed, show loading, and the error message appears from where user can retry. And at any step of this flow, user can cancel the file upload. If we try to draw a flow chart for this flow, it would look something like this. So here I illustrate the user actions and also system processes that should happen on response to this action. So user upload the file, then an application is showing loading indicator and sends a request to upload the file. And from this step, user can cancel file upload. However, if this doesn't happen, then we wait for a response. And if it is successful, we show success to the user from where they can cancel. Or if the request was if the request failed, Then we show error from where user can cancel, or they can also retry. And then they go to this loop, loading and retrying. So typically, when such a flow needs to be implemented, a developer, at least from my experience, including myself, would approach a situation in the following way. Just in case, I'm mostly working with React, and these examples are based on the pieces of code from the React. So firstly, we would define different states, like for example, file. We need to store file in order to be able to retry with it. And we need isLoading variable to show loading indicator. IsSuccess is also needed to identify if it was successful, and error message also needs to be stored. So imagine this is the file upload component, which is rendering smaller UI elements like file input, which is this add attachment button, and also based on the scenario, on the situation, different blocks for which are representing the file upload status. So it's loading, failure, and success. And we render these elements based on the states we have defined. And also, as you see, our elements are handling different scenarios, like what happens when user presses cancel, what happens on retry, here on cancel as well. And we also handle file input. And all these handling functions will live in the React component. You will need to handle different scenarios in a different way, even though it is about the same thing like canceling. For example, when you need to cancel a file which is loading, you need to reset different values in the state. So you will need to have different handling functions to handle a situation scenario in a certain way that it is required. So although this is a very simple example, this is a bad approach because we're creating quite convoluted logic, which is hard to understand and therefore easy to break. And if we will need to scale this flow by adding new steps, it will be very difficult and will become even more hard to read, to understand for other developers. And there is a big likelihood that such code will contain bugs. But we can look at the problem from a different point of view. And this is a finite state machine. Just one thing from my experience, like my first time when I met this concept was when I was working in N26. You most probably don't know this company, but this is a mobile bank which is quite popular in Germany, in Europe, and it was also in the UK, but they left UK, unfortunately. And I was working there on a customer support chat. We needed to build a web application for the chat. And this was very dynamic user flow, which required a lot of interactions. For example, there were steps like user verification with 2FA, and user could chat with a chatbot, or they could be in a waiting queue for a customer support agent. And all these scenarios needed to be handled. And I was very, very confused at the beginning. Like I was afraid that we missed some scenario, some flow. And I started to draw flow charts like I showed you at the beginning. And I discussed them with designers, with other developers, so we align on if we don't miss anything. And at the very beginning, the implementation was quite similar to the implementation I have just shown you. And to be honest, it was quite messy. And when we needed to add new steps like verification, it became very, very hard. And lots of people were just afraid to touch this code because what if you break it? This was the point where we looked into finite state machine concept. And it was one of the first and big refactorings in my life. We changed everything and moved the logic to a state machine. And from this real experience, I can say that it made our code more clean, and also the entire application more predictable and scalable, and it was much easier to test than before. So if we come back to the FileUpload flow, how do we approach it with a finite state machine concept? I have divided this flow into multiple slices or views. And for each view, I will define two things. The first one is state, and the second one is events. And these events are the events that can happen from this state. The first one is this is an initial one, and I call it idle. And possible events that can happen from this state are input, meaning user inputs a file. And when it is happening, then application is transitioning to another view, which is loading. And possible events that can happen from this view are cancel, if user interacts, or fail, or succeed, based on the response we get. And if it was successful, then we show a successful view, which I call complete. And possible events that can happen is just user can cancel it. But if it failed, then we show failure. And possible things that can happen is cancel or retry. And based on this, we can draw a finite state machine, defining all the states and also transitions. And we name each transition with an event we defined. So it's input, retry, fail, succeed, cancel. And the nice thing, if you follow this structure in your application, the nice thing about that is that there is no way you can be in idle and transition straight away to complete without reaching loading. It also prevents you from triggering cancel event and from failure go to loading. So such things are just not possible because you haven't defined them in your state machine. But this is already very good, but it's not enough to implement the whole functionality we need. And what we need is we need to trigger file upload when we enter loading state. So we can enrich our finite state machine with enter events. And we also need some data like error message and file, also file name to display it to the user, and file is needed to retry. And we can enhance the finite state machine with the context where all this necessary data will be stored. But as you see, this is not a finite state machine anymore. This is something much more complex. And in Frontend world, such a concept is called Statechart, which is a beefed up finite state machine. And here is the website where you can find out about different concepts, different like possibilities this pattern is providing. So, but in short, a state chart has enter exit events, automatic transitions, substates, actions, which are like a side effects, guards, which are conditions for a transition to happen. For instance, when the transition is not true, then you cannot transit to the next state. And the super nice thing about the state chart is that it has a history concept. So it remembers what was the previous state, and you can go back if it's needed. And there is, I think it's the nicest library that implements the state chart concept in JavaScript. It is available for vanilla JavaScript or for libraries like React, and I think also Vue. It provides you with all the functionalities that state chart concept has. And there is also one cool feature which I really like that I'm going to show you later. So when we start to work when we use Xstate library to implement a finite state machine, we will start from state machine definition. Basically, everything we need to define in our state machine will be in one object. And if we start from states definition, we'll define a field states where we will list all possible states. And also for each state, we will define possible transitions. And a transition here is just a key value pair, where key is the name of the event and the value is the next, the name of the next state. So only transitions that are listed here are possible. Anything else will just never happen. So we define states, and now we need to handle this onEnter event. When unloading, we trigger a file upload. So this is how library defines to set it up. You need to invoke a function which is responsible for file upload. And here is this function. To save time, I haven't put what is inside, but yeah, here we are preparing file for upload and doing actual request. And there are two scenarios. It can be successful or it can fail. And we handle these both scenarios. So, and on success, on done, we specify what will be the next state. It will be complete. And there are also some side effects we need to perform, or actions. And what we need to do, if you remember, on success, we were showing a file name, and it was like an indicator of successful file upload. And we need to save this file name to the context of a state machine. Yeah, this is assign method. It comes from the library, but under the hood, it's just setting a file name to the context. So, and on failure, we define also the next state, which is failure, and set error and file to the context of state machine. And we also need to define what will be an initial state from which machine will start, and the initial values of the context. So, and here, this is the feature I mentioned at the beginning. Xstate provides you possibility to visualize your flow. And here I have pasted state machine definition. It's completely the same like I showed you on the slides. The only difference is that I'm mocking upload function in order to simulate two scenarios, successful and failure. So we can go through the flow. The first state is idle, and when a user inputs a file, there is a loading state. And then it was successful, it was done. Machine transitions to complete state, from where user can cancel. However, if it will fail, we also can check this scenario as well. We show loading, and there will be an error which makes a machine transition to failure state, from where a user can retry, and it goes to loading again. Such visualization is very nice for you to see the entire picture of the flow. Also, you can show it to designers, for instance, to check if you are not missing anything. And it's a nice way to understand the logic of an application. And by creating such a state machine definition, we're moving the entire application logic to the state machine. So our UI component is responsible just for rendering the view, which it is supposed to be responsible for. And to see the benefits, I prepared a comparison before and after. So at the very beginning, I was relying on different states like is loading, error, is success. And due to some mistake, theoretically, is loading and is success could be true at the same time. But in case of using a state machine, we rely just on one value, the state, the current state. And based on it, we render a particular element. And it also allows us to use switch, which is much more readable. And there were lots of handling functions in our UI component, which are not needed with a state machine, because the only thing that a UI component needs to do is to send a necessary event to a state machine, and then state machine decides like what needs to be done. And in our case, we are in the failure component, and when user presses cancel, then this component is sending a cancel event to the state machine, and that will mean that machine will transition to idle state. And the same thing will happen with retry, but it will transition to loading state. So your component doesn't need to do to identify to decide like what to do with this scenario. It's up to state machine. And also we moved all the states from UI component to the state machine, and now we access error message, for example, from state machine context. So to sum up, this is a really good approach for event-driven and complex UIs. It's clean and readable and also scalable. And it's easy to test because you can control the flow by sending events to the state machine. And it's easy to visualize. Even if you don't use a library like Xstate, you still can draw a finite state machine yourself. And however, there are some cons as well. At the beginning, at least, it will be quite complex and time-consuming to implement because of some learning curve, and you can just jump on implementing, writing the code. You need to plan it, which is actually a very good thing. There is a risk of over-engineering it, because for very simple UI components, it's just not needed. You will make the code more complex than it should be. And yeah, I knew that I'm not on React Meetup. I'm on .NET Meetup, and that's why I have searched for some libraries for .NET, and I found one which is called Stateless. It looks like something we can trust because of amount of stars on GitHub, and also I have seen it's regularly maintained. And here I have posted an example from their documentation, This example is about an issue tracker. It has, so this state machine has 4 states: open, assigned, deferred, or closed. It's about bug. And I left only an example where they configure assigned state. It's a bit different. The configuration looks a bit different from each state because each state is configured separately, not like an X state in one object. And here, as you see, this library provides a possibility to set a substate. So this assigned state is substate of open. And it also gives, it says that from this state, a machine can transition to the same state if, for example, the issue is reassigned to someone else, I assume. And here is how they permit other transitions. For instance, on close, the machine transitions to closed, on deferred to deferred. And they also handle some side effects. When you exit this assigned state, you run on the assigned function, which is sending an email to assignee that they're not assigned anymore. So I would be into, I'm not working with .NET. The only experience I had was in the university, but I would be really interested if you give it a try and see like what you think. Was it helpful for you or not? And I had chance to work with PHP last year, and I asked my teammates, like, do they have any experience with state machines? And one example was from Symphony, which is a framework for PHP applications, and they provide also state machine like a pattern. But they advertise it like something you can use to implement different workflows. And here, as you see, their example is also based on the workflow, like a development workflow where you start a feature, you code, you test, and you review. And yes, they specify initial state, which is start, and also all possible transitions. A little bit in a different way, but still like all machine configuration is in one object, which is similar to X state. And there is one similar concept, which one of my teammates, who is a backend developer, shared with me. I haven't dived into details like how exactly it works, but I liked very much how they state the problems they are trying to solve with this state pattern. The first one is state-specific behavior should be defined independently, and adding new states should not affect the behavior of existing states. And I think this is what finite state machine on frontend also solves. So here you can find the examples. There will be a file with this bed solution and a file with a finite state machine solution. So thank you very much.